Hello. In this video, I'm covering section 6.2 on the set of integers. So we mentioned in section 2.1 that the set of integers is going to be the set of whole numbers with their opposites. So the set of integers we don't have a first or last term. That's going to be one way to indicate the pattern is with -3, -2, -1, 0, 1, 2, 3, and so on. It's going to be the set of whole numbers and the opposites of the natural numbers. So in this section, we will suppose for a moment that we haven't learned how to add or subtract integers. So I'm going to read this part. A common model that we can use to explain the addition of integers is movement on the number line. In this model, we think of integers as points on the number line, as shown in the figure. So our starting point is going to be 0. Beginning at 0, we interpret positive numbers as movement to the right and negative numbers as movement to the left. Okay, so I'm going to do example 1. So this is an example of adding and subtracting integers. Assuming that we have never done that before, even though we have been doing things more complicated than that in this course. Okay, so we are going to perform the following additions on the number line. So in A, we are adding +3 plus +5. Okay, so we have our number line, and our starting point is going to be 0. Okay, so +3 plus +5, +3 is going to be starting at 0. We move 3 spots to the right. And then plus +5, starting at +3, we're going to move 5 spots to the right. Our starting position was 0, and our ending position was 8. So +3 plus +5 is going to be +8. Now, this is the most basic material that we're covering in this course. But when you're doing the homework, you need to be careful about how you enter the answer. So let me show you. I'll show you what the homework in this section looks like. So I'm opening the assignment, and I'm going to share the screen. Okay, actually, let's start with number 9. Let's start with number 9. They are asking us to calculate the indicated sum, or doing the operations. So let's move. Yeah, I'm looking for someone with a positive answer. Okay, so let's do that. Positive 19 minus negative 5. You know that this is positive 19 plus 5, and the answer is 24. But if you only enter 24, it's not going to give you credit. You need to enter positive 24. This is only for this section, but the way you enter the answer matters. So that one is negative. I'm going to skip it. That one's also negative, but still. If it's negative, you enter the answer. And positive 3 times positive 6. If you only enter 18, it's going to count it as wrong. Well, actually, that did. That did is just with addition and subtraction. Actually, multiplication and division is fine. It's only with addition and subtraction that you need to enter the plus part. So that one, yeah, that one, if you enter again, if you only enter 22, it marks it incorrect. You need to enter the plus. Only with the problems with summations. Everything else seems to be fine. Okay, part B. Add a positive 9 plus negative 12. Okay, so let's start at 0. Yeah, we're going up to positive 9. Okay, our starting point is going to be 0. Okay, so we move 9 spots to the right. That's positive 9 plus negative 12 plus negative 12. We're going to move 12 spots to the left. And the result is going to be negative 3. So our ending spot was negative 3. So positive 9 plus negative 12 is negative 3. And part C, okay, part C is going to be hard to do it on a number line. So I'm just going to read the explanation. So number 3, it's not practical to draw a number line when calculated with such large numbers, like negative 149 plus positive 137. However, you still can imagine movements along the number line. If you visualize moving 149 units to the left and then 137 units to the right, you see that the net effect is that you have moved 149 minus 137 equals 12 units to the left. So negative 149 plus positive 137 is equal to negative 12. So that's part C. So that's again negative 149 plus positive 137 is equal to negative 12. The next definition is the definition of opposite integers. Two integers, x and y, are opposites or additive inverses if and only if x plus y is equal to 0. So that's page 251. So examples of that can be -7 and 7. Or if we're picky about that, that's +7 and -7, or -15 and +15. So on a number line, we're going to have that they are going to be at the same distance to 0, but they are going to be on opposite sides. So -7 and 7 are going to be opposites. They are the same distance from 0, but on opposite sides. So these two are opposites. And -15 and 15 are also opposites. So these two are also opposites. With that in mind, with the definition of opposites, we can define subtraction of integers. So this is nothing you didn't know before. And not because I mean we have done we have been doing arithmetic since the beginning of the semester. But with integers, if a and b are integers, then a minus b is the same as a plus the opposite of b. So a couple of examples. Five minus 9, it's 5 plus the opposite of 9. And I'm sure you know the answer. You know that this is -4. Or 21 minus -34. This is the same as 21 plus the opposite of -34. So that's going to be plus +34. And the answer is +55. So more basic arithmetic, subtracting, or not subtracting, multiplying and dividing integers. So that's still basic arithmetic. I'm just going to read the situation in the book. So you can understand the rules for multiplying integers if you consider the following model. So today day 0, and assume that you have $100 in your wallet. Also assume that each day, one of two things happen. Either you receive $5 in the mail from your rich uncle, or you spend $5 for a pizza. We assume that you're making other changes in your finances. We will now consider the product of integers a and b. The integer a will represent changes in days. So a positive a represents days in the future, and a negative a represents days in the past. The number b will represent changes in your finances. A positive b means that you receive $5, and a negative b means that you spend $5. For example, we interpret positive 3 times -5 to mean that for the next 3 days, you spend $5 each day for pizza. The product -4 times +5 means that for the past 4 days, you have been receiving $5 from your uncle. With this in mind, consider the next table. +3 times +5 means that for the next 3 days, you receive $5, so you will gain $15 in 3 days. The rule is that a positive times a positive is a positive. Now let's suppose, or the multiplication +3 times -5 means that for the next 3 days, you spend $5, so you will lose $15 in 3 days. And in general, a positive times a negative is a negative. Next multiplication, -3 times +5. You can interpret this as for the past 3 days, you received $5, so you had $15 less 3 days ago. In general, a negative times a positive is a negative. And last multiplication, -3 times -5 equals +15. So for the past 3 days, you spent $5 and you had $15 more 3 days ago. In general, a negative times a negative is a positive. The general rule is that if A and B are integers, the product of two integers of the same sign is positive, and the product of two integers of opposite signs is negative. So, examples. -6 times -9. Negative is positive, so the answer is going to be +54. -3 times +4. Negative times positive is negative, and 3 times 4 is 12. Next, +12 times -2. Positive times negative is negative, and 12 times 2 is 24. And +7 times +4. Positive times positive is positive, and 7 times 4 is 28. So the answer is going to be +28. So I talked about divisibility last time. We can now define division between two integers in terms of the multiplication. If A, B, and C are integers, then A over B equals C means that A equals B times C. So let's do example 3. Okay, let's suppose for a moment that we don't know the division rules. Okay, so using only the definition of division, find each of the following quotients. So let's suppose that we haven't learned how to divide. At this one, I'm pretty sure that you already know the answers. So in A, if we use the definition of division, we let +6 over +2 equals C. Then the definition of division says that +6 equals +2 times C. And we know that the number that multiplied by positive 2 is equal to 6 is 3. It's positive 3. B, let positive 12 over negative 6, let's call that C. Then positive 12 equals negative 6 times C. So the number that multiplied by negative 6 is equal to positive 12 is going to be negative 2. Part C, negative 15 over positive 3. Let's call this C. Then negative 15 must be equal to positive 3 times C. So if we want to obtain negative 15, we need to multiply C. We need to multiply negative 15 by positive 3. So C is negative 5. And part D, negative 20 over negative 5. So we're looking for a number that multiplied by negative 5 is C. In this case, C is positive 4. So the rules are going to be the same. The rules of sign, a quotient of two numbers with the same sign is positive, and a number of, or the quotient of two numbers with opposite signs is negative. So that's page 254. And I'm going to do two more examples. We have expressions that are a little bit more complicated. This is an exercise with the order of operations. We're going to simplify the expressions. So those are on page 255. As you can see, this section doesn't take too long. Okay, so we're going to simplify each of the following expressions. Let's start with number 40. Okay, so that's on page 255. Five plus negative 9 times 10 minus negative 4 over negative 3 minus 4. Order of operations, we first are going to simplify the parentheses, then multiplication and division, and then addition and subtraction. So 5 plus negative 9 is negative 4. 10 minus negative 4 is positive 14. And negative 3 minus 4 is negative 7. Next, do multiplications and divisions. Positive 14 over negative 7 is negative 2. And finally, negative 4 times negative 2 is going to be positive 8. Or in the homework, you can leave it as 8. It's just with addition and subtraction that they want you to write it with plus. So you can just write 8 or positive 8. And number 42. Simplify. Simplify this expression. Order of operations, we first simplify the parentheses and then multiplication and division, and finally addition and subtraction. Okay, in this parenthesis, we have first 3 plus 9. And we have -1 minus 2. Next, we have 8 minus -4. And 7 minus positive 9. $12 over -3 is -4. And 12 over -2 is -6. Final answer, -4 times -6 is 24, positive 24. Okay, so this section covered the most basic material in this course, how to add and subtract on a number line. So I'm going to stop here. Thank you for listening.